when the reaction is happening and A plus B giving some product R, continuously the reaction, to what extent the reaction will happen, that is an important issue. All A and all B will not convert into the product R. If at all you want to do, you need to change some operation parameter that we'll see later. So at a certain instant, the rate of forward reaction will be equal to the rate of backward reaction. That means at that condition where the concentrations of all reactants and products remain constant.
Okay,
So
that
that
is
is
called equilibrium.
equilibrium.
Okay.
Thermodynamically, if you talk about the equilibrium, is it's a steady state dynamic state where that reaction system attains or reaches lowest possible free energy level. So a system, first of all, we should know that a system, any reaction system will be at equilibrium when it has certain minimal possible amount. Then reactions that take place
Hmm.
in reduction form and oxidation form.
Hmm.
Reaction may be reduction or oxidation. That also we'll see. And what is the electrochemistry?
That means the
That we will
concentration
discuss in
levels
unit
of
7.
we are reducing and increasing. Oxidation and huh?
No, no, not that. Redox means addition of
Hmm. Redax means
electron
what? What
or
redax means?
addition of electron or removal of oxygen reduction reaction.
Hmm.
Oxidation means addition of oxygen or removal of electron.
Yes, that is correct. Next.
Then chemical kinetics, when the reactions are happening, the concentration of each component in the reaction system may continuously change with respect to time. How that concentration is changing with respect to time, that is the basic information required for us to design big reactors. So this is up to this, it is
Chemical kinetics.
physical chemistry.
Okay.
Then coming to the inorganic chemistry, there are two types, organic chemistry and inorganic chemistry. Organic chemistry mainly deal with the compounds that are
Combined with
formed
the carbon.
basically by carbon.
Hmm.
So other than that carbon, if any elements are there that are there in the inorganic chemistry, mainly in the inorganic chemistry, we will discuss about what are the elements, what are their properties, how they can be classified into groups and periods, what is the main trend that the elements will follow based on their electronic configuration. That and all will be done, known in a periodic table. Next, this periodic table is divided into four blocks:
Hmm.
S black, P black, D black, L F black.
Hmm.
So these blacks are defined based
On
on
what
the
basis they are
outermost electron
dividing?
that is
On
present.
what basis they are dividing the blocks? Any fundamental concept is there, or how they are dividing into blocks?
The respective black
Hmm. Tell me.
signifies the out system, a systematic order, like energy levels.
Hmm.
So which energy level it is, which orbital it is. In other words, S orbital, P orbital, D orbital, F orbital, S, P, D, F.
Hmm.
So based on the outermost electron, the respective element will be in that respective black.
Hmm.
Next slide.
Hmm.
Similarly, D black and F black. Only what we know how the elements are grouped into blacks is based on the outermost electron that present in that element, whether it is S, P, D, F. And coordination compounds that
No,
are
no, no, no. My question is, if new element
uh,
is would like to place into the existing 118 table, what are the
periodic
parameters
table.
we are checking?
I need to tell the period, take the periodic table and discuss.
Okay.
Hyperlink I need to have. Otherwise, while I am going, I will see that.
Hmm.
Normally, for PPTs, we need to have hyperlink. Do you know what is that hyperlink?
I know if you click that one,
Uh,
it will refers to
Suppose when we
something.
are talking about periodic table, now we should have a hyperlink to the periodic table, like that.
No, you are a chemistry person. You need to know 118 elements before going to explain all the table of elements and columns and rows and orbitals,
Yeah,
four
when we go in
orbitals.
detail, we will discuss about it.
Yeah, yeah,
What is group?
continue.
What is column? What
Yeah.
is
How they
row?
have kept in the table, what is the reason behind that, and how easily we can segregate all the elements comes to S, P,
Only
E, F.
the periodic table information gives us the orderly arrangement of the elements to read their properties in common,
Yes.
to easily understand the behavior of the elements.
Yes, structure of the element, properties of the
No, no,
element,
structure periodic table
structure.
it doesn't give the structure.
No, no,
It
properties,
gives only the information,
behavior,
physical information it gives,
characters,
like atomic number.
characteristics. Many things will come into the
Pardon?
picture. Characteristics, properties, and behavior of the
Properties, that's what.
element. Everything it will come into the in that periodic table. Not you are
Structure will
saying
not come. Structure
yeah,
will not
structure
come.
it won't come. It's okay, but the elements related to same structure it will come into the same row or column in the table. Okay, leave
No,
it.
no, 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 no. Structure point of view, it is not like that.
It's okay.
Structure is
Leave it.
entirely
Leave it.
different.
Leave it. I know structure. Okay, I know
You know
structure.
now.
Leave it. Next.
Uh, so up to that, your syllabus for IIT chemistry is
That is
uh,
inorganic chemistry. So far you have
inorganic
next.
chemistry.
Ah,
Next, coming to the organic compounds,
yes.
compounds that containing mainly carbon,
Yes.
dealt with carbon, it is called as organic chemistry.
Yes.
In this, purification and characterization of the organic compounds, we come across so many organic compounds. How to
Yes.
purify them into that form?
You
Most
just
of the farmers,
correlate. You just correlate with the real time where we are
that's
using
what.
carbon.
నేను అదే చెప్పబోతున్నా మళ్ళీ నాకే చెప్తున్నావు.
Sir, cheppu.
Most pharmaceutical products, for example, most of them are organic compounds only. For
Yes.
example, you see penicillin, terramycin, injections, paracetamol, all these are organic products only. Into purest form, paracetamol in the purest form, how you take. Sometimes 1% or 0.1% of the contaminants also will affect or side effects will be there if you consume as a medicine. So that is the reason purification is so important in real time. And what are the properties of those organic compounds? These are dealt in that this chapter. Then what are basic principles of organic chemistry? What is carbon? How it is different with other elements? That and all we'll discuss in unit 14. Hydrocarbons, carbon and hydrogen compounds, molecule, carbon and hydrogen molecules together form
How you
hydrocarbons.
can
Most
define
of
a
them
atom
are,
and molecule?
they contain carbon and hydrogen.
Hmm.
Uh, Almost all of them are fuels
Yes.
like petrol, diesel, kerosene. These are all fuels only. So they
Yes.
are all hydrocarbons.
Okay.
Okay. Then organic compounds containing halogens. Halogens means fluorine, bromine, bromine, iodine, astatine, seventh group.
Yes. Correct.
So when these halogens are connected with combined with organic compounds, that is one unit, unit 16. Then organic compounds containing, for example, you see halogens, organic compound halogens, chlorofluorocarbons, chloroform, like that. Then
Yes.
organic compounds containing oxygen,
Yes.
carbon, hydrogen, and oxygen. Mostly hydrocarbons are there. One hydrogen is replaced with oxygen, or it may be bonding with some other carbon like that. So carbohydrates, for example, carbon, hydrogen, oxygen. So most of them carbohydrates. Similarly, organic compounds containing nitrogen. You have seen that trinitrotoluene. Toluene is
Yes.
C6H5NH3,
Yes.
NH2. So amine group, if an amine group is added, it is toluene.
Yes.
So like that, trinitrotoluene, two times of toluene is there, nitrogen group is there, that is an explosive. Like that, there are so many compounds, we'll see it later. Then the biomolecules in the living cells, all our bodies, all living organisms, either plants or human beings or animals, whatever, they're made up of biomolecules.
Yes, correct.
So they are carbohydrates, lipids, uh,
Enzymes,
carboxylic acids, enzymes,
enzymes.
so many. We'll see in detail. Then, what are the principles related to the practical chemistry? Suppose if you are taking one element, one compound, sodium chloride salt you are taking, what is the amount of the sodium chloride in that? How much contaminants are there? Sometimes sodium iodide also will be there. You have seen Annapurna iodized salts, they are saying, na, it means instead of chlorine, iodine also will be there. Sodium chloride and part of sodium iodide. Iodine is very important for the body. If
Yes,
iodine is lacking in the body, we will get goiter disease.
yes, yes, sir. Goiter disease. Yes.
So these are like compositions, any contaminants, how much amount, like that we can discuss in this practical chemistry.
Okay.
So we
Explain.
know it is the branch of science that studies composition, structure, properties, and if it changes from one form to the other form, including the interactions between different substances. As of now, 118 confirmed elements are there in the periodic table, ranging from hydrogen to agonation, that is element 118.
Yes.
So, the how chemistry, modern chemistry started. So, the father of the chemistry is often regarded as Antoine Lavoisier, 18th century. He has found the law of conservation of mass and found some other elements. Then we have
What
seen
is
that
matter?
organic chemistry, inorganic chemistry, physical chemistry. These
Yeah.
are the three broad chemistries. Actually, these are the chemistries broad classification. This classification is also not to my satisfaction. It's not good. Okay, get on, get back. Next.
No, these are the eight types of chemistry. Okay, first you need to
No,
explain from this one. There are eight types of
already I
chemistry.
have discussed about the organic chemistry, inorganic chemistry, physical chemistry. These
Yes.
are the three broad classes. Broad
Majorly
classes.
classified into three types, but broadly
Then we go
classified
for
into
some other
eight
stuff.
types. Yeah. Explain.
Analytical chemistry focuses on techniques, methods for analysis. How much amount is there? What is this composition? What is the concentration like that? And biochemistry, it is a chemistry related to biological materials in living organisms, what reactions happening and all. Environmental chemistry, the study of chemical processing occurring in the environmental surrounding places and human activities on this process. Industrial chemistry related to the products that we produce in factories. Theoretical chemistry, it uses some mathematical models and simulations to understand chemical behavior and predict some chemical phenomena, what it happens inside actually, like that.
నువ్వు ఈ ఎయిట్ టైప్స్ కన్నా కరెక్ట్గా సార్కు రవి సార్కు చెప్పగలిగినావు విత్ ఎగ్జాంపుల్స్ అంటే
ఇది క్లాసిఫికేషన్ హలో హలో
విను.
ఇది బ్రాడ్ ఈ క్లాసిఫికేషన్
క్లాసిఫికేషన్తో పాటు ఎగ్జాంపుల్స్ నువ్వు చెప్పుకుంటా వచ్చావు అంటే సారు ఒక రేంజ్లో
అవి చెప్తా
పెట్టుకుంటాడు.
కానీ
చెప్పు. నాకు
ఈ
చెప్పు
థియరిటికల్
ఫస్ట్, నాకు
కెమిస్ట్రీ
చెప్పు. నాకు అర్థమైతే మళ్ళీ సార్కి అర్థమైపోతుంది.
త్రీ బ్రాడ్ క్లాసిఫికేషన్ ఆర్గానిక్ ఇన్ఆర్గానిక్
దట్ ఈస్ లీవ్ ఇట్.
ఫిజికల్
నౌ ఎయిట్ టైప్స్
అట్లా
ఆఫ్ కెమిస్ట్రీ ఐఎమ్
ఎయిట్
గివింగ్.
టైప్స్ ఎయిట్ టైప్స్ లో చెప్పకూడదు క్లాసిఫికేషన్, ఇది కరెక్ట్ కాదు క్లాసిఫికేషన్.
బ్రాడ్లీ త్రీ టైప్స్.
ఈ బేస్డ్ ఆన్ ఫిజికల్ ఇన్ఆర్గానిక్ అండ్ ఆర్గానిక్ కెమిస్ట్రీ we define these chemistries అంతే,
Yes, you define now.
సబ్ గ్రూప్స్.
You explain now analytical chemistry, biochemistry, environmental chemistry. Where we are using, why we are using, what are the.
ఇప్పుడు
Ah,
ఇప్పుడు చెప్తుంది ఎగ్జాంపుల్ చెప్పినా కదా నేను.
చెప్పు.
ఏదైనా ఒక మెటీరియల్ సబ్స్టెన్స్, ఇఫ్ యూ టేక్ ఎనీ సబ్స్టెన్స్, వాట్ ఈస్ ప్రెసెంట్ ఇన్ దట్, హౌ మచ్ ఈస్ ప్రెసెంట్ ఇన్ దట్,
Hmm.
qualitative and quantitative tests we have to do. There are some techniques.
Hmm.
So techniques dealing with analysis of the substances is called as analytical chemistry.
Correct, correct. Next.
Based on a certain principle, will do it. For example, if you take the chromatography is a process of selecting, observing one substance based on its molecular interaction. Suppose, for example, distillation, if you take separate out based on the relative volatility of the compounds, like that, based on certain principles, we'll make use of some techniques From that, we will find it out the concentrations and compositions and their presence, whether it is presenting or not. If present, how much, like that. So biochemistry, it is a study of chemical process within the living cells, mainly the enormous reactions continuously happening in living cells. These cells are associated, supplemented by some enzymes. They are called as enzymes, biological enzymes. So, how these reactions happen and all that will be dealt in biochemistry. Mainly when, for example, ozone is getting depleted. We are saying that every day, ozone depletion is there, greenhouse effect is there,
Yes.
global warming is there. We are saying that. So, how this global warming? What is happening in fact? Global warming is nothing but that increase of the temperature. And ozone is the outermost layer of the atmosphere is ozone. There's a big, thin, thick layer of ozone is there. If ozone is depleted, some ultraviolet rays will be coming on the earth.
Yes.
So whatever the
It
sun,
will harm us for a human being. Yeah.
when sunlight falls into the enters the environment, ozone layer will reflect back the UV light. UV light. If any ozone is getting depleted, that light will come, and that UV is falling on our skin. Will get skin
Ultraviolet
cancer.
rays.
UV rays, ultraviolet rays. So global warming, with the presence of the carbon dioxide is more. Presence of the sulfur dioxide is more. What happens? Whatever light that falls on the earth, that will be reflected back to the environment again. So because of the higher concentration of the air, some part of the energy heat will be absorbed by those elements, and the surrounding temperature will increase. That is global warming. So, like that, environment will have some effects, some chemical associated by some chemicals. So that is the reason it's important to study the environmental chemistry. Then, while we are producing products, say for example, you need some injection, some say for example, COVID co-vaccine. That is one molecular product. We produce it. So to produce that in larger quantities, how best to make use of these chemical reactions? So what is the behavior of that reaction that happen like that? In large scales, we need to produce products. For that, we need to follow some techniques and systems. So that is dealt in industrial chemistry. So theoretical chemistry, actually, I am not happy with this theoretical chemistry. It uses the mathematical models and some simulations to understand chemical behavior and predict chemical phenomena.
Yes. Now
As
coming.
we know, so now we come to actual topic. What is matter and how is it? What is the nature of the matter? So normally we say, what is matter? What is the matter, like that we say, and not that matter. So in chemistry language, the matter is anything that has some mass and occupies certain space, some volume. That is called as matter. As per the chemistry, matter is a substance or something that occupies space and have has some mass. That is matter. Matter exists in different forms: solids, liquids, and gases. Don't ask. There is another state of matter, plasma, that is not stable. So, for
Yes.
the reference, we just talk about in the as long as we are on the earth, we are concerned about the solid, liquid, and gases only.
Three types only. Yeah.
Uh, then why these solids, liquids, and gases are why this matter behave like this and all that depends on different parameters. So we'll discuss that in physical chemistry part at the end. Then Dalton has proposed a certain theory related to the atoms, saying that atoms are individual particles. They combine to form molecules and compounds. Atoms, just like that, they cannot keep quiet. They used to react with the other atoms, like atoms or unlike atoms, to form the molecules and compounds. That was the theory proposed by Dalton. Then, one atom is reacting with another atom and giving some other product. They are all governed by certain laws of chemical combination. How they are being combined. These laws govern the ways elements combine to form products,
Mm.
including the law of conservation of mass and law of definite proportions. If at all A and B is reacting to form some other product C, in what proportion they are? 1 mole of A, 1 mole of B giving 1 mole of C, or 1 mole of B, 1 mole of A giving 1 mole of D. Like that. That is the definite proportion
Mm.
in number, natural numbers, 1, 2, 3, and so on, like that. So when we are talking about this atom, it has certain mass. Already when we are talking about the matter,
Mm.
we have defined that matter is nothing but something that has mass and occupies some space. So what is the atom? When you take a simple atoms, single atom, what is the mass?
Mm.
So mass is the weighted average of an atom, and molecular mass is the sum of atomic masses in a molecule. For example, you take atom is there. What are the subatomic elements in that? Atom
Mm.
consists of electron,
Mm.
proton, and neutron.
Yes.
Comparative to proton and neutron, electron mass is very less.
Mm.
Therefore, we, when we refer atomic mass, it is the mass of protons and mass of neutrons.
Mm.
Almost there is a slight difference between an neutron and proton in their masses. Proton is positively charged, neutron is neutral, electron is negatively charged. So compared to two, in terms of mass, almost neutron and proton can be regarded as same. So the mass of proton and neutron within a atom is called as the atomic mass. If there is a molecule, it may be made up with so many atoms, like atoms or unlike atoms.
Mm.
So these atoms all together added to give the molecular mass. Right.
Mm.
Next, when we talk about the mole, this is very important. Here, so many people are confusing here. 1 mole of any matter, any substance, is equal to its molecular mass. Molecular mass, what is what? Molecular mass, what we say? It is sum of the masses of all atoms present in that molecule.
Mm.
So, if the molecular mass is expressed in grams, for example, sodium hydroxide is a molecule. The molecular mass of the sodium hydroxide is 40. Therefore, 40 grams of sodium hydroxide is 1 gram mole.
Mm. Next.
So, gram and sometimes we do 1 mole we say. That means by default it is gram mole. There may be a kg mole also. You
Mm.
will see in future.
Mm.
So by default, 1 mole means 1 gram mole. If it is 1 kg mole, that means 1000 kg gram moles, like that. So sulfuric acid molecular weight is 98.
Mm.
So that means 98 grams of sulfuric acid is 1 mole.
Mm.
Similarly, calcium carbonate molecular weight is 100.
Mm.
Then 100 grams of calcium carbonate is 1 mole.
Mm.
Why we unnecessarily calling this mole, the important thing, the miraculous thing is that if you take any gram or any material of 1 gram mole, either it is carbon dioxide or it is oxygen or it is calcium carbonate or it is sulfuric acid or something else. If you take 1 gram mole, that 1 gram mole will consist of 6.02 to 10 power 23 of that molecules. That is the miracle.
Avogadro number.
That is called as Avogadro number.
Mm.
44 grams of carbon dioxide is 1 gram mole. 98 grams of carbon dioxide is 1 gram mole.
Mm.
100 grams of calcium carbonate is 1 gram mole. That
Mm.
means
Mm.
in 100 grams of calcium carbonate or 44 grams of carbon dioxide or 98 grams of sulfuric acid, there will be n number of molecules only.
Mm.
That is the miracle. Okay.
Mm. Next.
Next. When we are taking a mixer, components, a mixer consisting of A, B, and C, how to find out the concentrations of these in percentages, in fractions, something like. Suppose if you take, there is one mixer, 10 grams of A, 20 grams of B, 30 grams of C is there. If you add them, if you want to express them in the percentages, so mass of A divided by total mass multiplied by 100 will give you the percent per 100. If you take 10 grams of A, if it's 20 grams of B, 30 grams of C, it will give you 60.
Yes.
If you want that in percentage, if it is 60, what how much amount? If it is 100, how much amount? 100 percentage is the reference for the convenience. So like that will
Divided by
mass of
100 into multiplied by 100.
mass of component divided by the total mass multiplied by 100 will give you the percentage of that component what we are referring.
Next.
Percentage of A is different, percentage of B is different, percentage of C will be different. Then empirical formula and molecular formula. We know the what is H2SO4 is the molecular formula for sulfuric acid.
Yes.
Calcium carbonate CaCO3 is the molecular formula. Suppose if we are able to write this molecular formula multiplied by a whole number,
Ne-
especially in the organic chemistry, we see that ethane C2H6 CH3 multiplied by 2. That way you can say. So C2H6 is the molecular formula for ethane and CH3 is the empirical formula for ethane. So if empirical formula is multiplied by a natural number, then the molecular formula will come. Must be very clear. This is clear.
yes. Next.
Then
No,
we are saying
suppose
the reactions are
suppose
happening.
suppose H2SO4. So what is molecular
H2SO4
formula and what is empirical formula?
empirical formula we cannot find for that.
Why? Why?
If there is a common proportion,
Yes,
there
H2SO4.
is a
Yeah.
H2SO, how will you write? One sulfur is there, four hydrogens are there. Two, suppose if at all if you want to write H2SO4,
How do you can
if
write?
you take two outside, H, S by 2, O2 like that, you can, that is not possible. Half molecule will not be there.
Okay.
So that will be in proportion of natural numbers only.
Okay.
If that
Next.
is possible, then only empirical formula exists. There will be molecular formula for all elements. There won't either there may be or may not be the empirical formula for any component. That is an optional. Sometimes empirical formula, getting empirical formula is convenient in organic chemistry. We'll
No,
see when the section.
actually, molecular formula shows the actual number of atoms. Now, how many atoms are there
Yes,
in the
yes, yes,
H2SO4?
yes.
Okay.
Uh,
I'm asking what is the empirical formula for H2SO4?
empirical formula for H2SO4 is not existing.
Why?
For
There
all
is
the
there is
for
no
all
whole
the
number.
molecular,
There is
listen,
no.
listen, listen.
Uh,
Let me tell you. For it is not mandatory that every molecular formula will have empirical formula. If these elements are available in a certain proportion,
okay.
then it is possible to write the empirical formula.
Okay. Leave it. Next, eighth. I understood.
Then, when the reactions are happening, this is represented by a chemical reaction. For example, A plus 2B give you some product R. If this is the reaction, this is called as chemical reaction. Then what is the stoichiometry? A plus 2B is giving 2C, for example. So 1 mole of A is reacting with 2 moles of B to give 2 moles of C. That is called stoichiometry of that reaction. Or if 1 mole of A, 1 mole of B give 1 mole of C, that is also stoichiometry of the reaction. The stoichiometric reaction represents that the proportion among the
Quantitative. How many number is there?
reactants and products.
Mm. What is the size? What is the number? Quantitative. Yes.
Actually, not in the sense of lumber, in terms of moles, actually.
What is mole? How do you can
Already we
define
discussed it.
mole?
Already
How?
we have discussed it. Not mole
No,
is
no,
nothing
no.
but
How you can say
molecular mass equal to that.
what is mole? It is a measurement of any mass.
Yes, it's measurement of any mass in chemistry.
Yes.
Just like that, where for vegetables we are using kilograms, na. That is
Yes.
easy for us to purchase and take. But in
Yes.
chemistry, it's a science.
Mm.
So it is convenient to represent them in the form of moles.
Yes.
That is the
Next.
reason mole was defined.
Okay. Next.
Then radiation. Radiation is nothing but the form of energy.
Mm.
Electromagnetic radiation means it's a resultant force
Mm.
of electricity and magnetism.
Mm.
So energy can be in any form.
Mm.
One of the forms of energy is radiation.
Correct.
Electromagnetic radiation means it's a resultant of the electricity and magneticity. Just like, for example, light. Light is an electromagnetic wave,
Flow of
or
electrons.
radio waves. Even our what do you call um, signals, cell signals also electromagnetic waves. So like that, there will be electromagnetic radiation. That electromagnetic radiation will have
Speed
what you
of the
call
light and exhibit
dual
wavelength.
nature. Dual nature. That
Mm.
is, particle behavior will be there, wave behavior will be there.
Mm.
And if you take some metals, if you expose some radiation onto that, outermost cells will have free electrons. Those electrons will come out. That emission of that electrons is called as photoelectric effect. Because of energy, that is light we are exposing on that,
Mm.
some electrons will escape from that. That process is called as photoelectric effect.
Mm.
And Bohr is a scientist, Niels Bohr is a scientist. He proposed one model for an atom where an electron is revolving around its nucleus in a fixed orbit. That is called as energy level. Unfortunately, the explanation proposed by Bohr was applicable for only one electron within a atom. So that was applicable for only hydrogen. For multiple number of electrons, that theory was failed. Then matter we are saying that we have seen that it exists both wave-like and particle-like behavior. That was proposed by de Broglie's dual theory. Some hypothesis. Hypothesis. What do you know? What do you mean by hypothesis?
Hypothesis means you have collected all the rules and regulations, formalities, everything, and you are making one database. From there, you are asking any question, it retrieves the information from the existing.
Okay.
That is
Let me tell
called.
you,
Mm.
in a layman concept, I will tell you the in terms of data science writer, hypothesis is just an imagination or an
Mm.
assumption.
Mm.
We will assume that this will be like this. We will hypothesize that, and based on if we hypothesize that like that, this should be like this. If it is so, then our hypothesis is right. So
Yes,
it is
yes.
an assumption, an imagination.
Mm.
That can be practically proved, then it is okay. Just like mathematical induction, what we are saying, for n equal to 1, where it is satisfied. For n equal to n, we are writing. For n equal to n plus 1, we are showing it to be applicable. Is it?
Mm.
Like that, by hypothesis, we can find out. That was proposed by de Broglie. Heisenberg is another scientist. He says that when electron is rotating around its nucleus, it's impossible to simultaneously, that is very important. You can measure the exact position, you can measure the momentum, but at a particular location, at a single time, you cannot find out both. That is uncertainty principle. Heisenberg has proposed that simultaneously knowing exact position and momentum of an electron while it is rotating is highly difficult. Then quantum mechanical model of atom. Describes the electron as a wave function in orbitals with specific quantum numbers called energy levels and their shapes. That is what orbitals were saying. When electrons are revolving around the nucleus, they are going around a certain path. That path is called as an orbital. Each orbital can accommodate two electrons. The position of that electrons depends upon the energy level of that path. Each and every orbital has its own energy level. Arrangement of the energy levels in their order, we'll see that Hund's rule, we'll see. Abo principle, always exclusion principle, and Hund's rule. These are all the rules guiding the arrangement of the electrons in orbitals, emphasizing the energy levels, exclusions, and maximum multiplicity. We go in detail in that.
Okay.
So when electrostatic attraction, that means there is a positive charge, there is a negative charge. So like poles, like charges repel, unlike charges will attract. So electrostatic attraction is nothing but the attraction between two positive and negative charged ions. Covalent bonding means it is sharing of the electrons between atoms to achieve the stable configuration. So electrons are arranged in such a way that if they have to be stable, then they may share. One atom may share with the other atom. For example, you take chlorine. Chlorine atom is there. Why chlorine is not existing as a single atom? It's existing as Cl2 because at stable configuration, it mixes with another chlorine and become chlorine molecule, though they will share electrons. Then, when the materials, this matter is existed in the form of a lattice, that is, this, many of the solids are in crystalline form. Crystalline form means the lowest possible existence level. That means if these molecules are having energy associated with them, if it is possible for you to decrease those energy to the extent of the possibilities that they can exist, that is crystalline state. And crystals are arranged in the, they will have some lattice. Lattice means definite arrangement. Some structure, if you see, that is a lattice. So different types of lattices are there. So when they come, these are brought up. If you want to spoil the lattice structure, lattice enthalpy energy you have to add. So this is what the energy released when gaseous ions form from a solid ionic lattice. Not gaseous, anything you can say. Valence shell electron pair repulsion theory. So valency means the outermost electrons, valence electrons. So if those a cell that consists of valence electrons outermost shell, that is called as valence cell. If there are two pairs of electrons, so they repel with each other. So it predicts the shapes of molecules and based on the repulsion between electron pairs. Say for example, carbon dioxide is one structure, H2O, water is one structure,
Yes. Structure is
calcium carbonate
different.
is one
Structure is
structure.
different for every
As a
compounds.
result of the structure of those elements as a result of valency shell electron pairs because of the attractions, because of the repulsions, the resultant structure will be like that. So that is the
Yes.
valency shell electron pair repulsion. So variation of the structure is because of that. Then
Okay.
valency bond theory and hybridization. Covalent bonds formed by overlapping atomic orbitals. If s orbital is there, p orbital is there, they can overlap and they'll become hybridized orbital. So these covalent bonds formed by overlapping atomic orbitals and hybridization involves mixing of s, p, and d orbitals. Complex orbitals will be formed. So a s orbital, for example, it will be in a rotating in a spherical path. P orbital it is in a dumbbell path. If s and p are hybridized, it will be differently it becomes. So that is called as hybridization. So orbital theory. It describes the bonding in molecules through molecular orbitals formed by the combination of atomic orbitals. So if you take a molecule it will have atoms. A molecule is
Molecule is a
made up of
combination
which,
of atoms.
like or unlike molecule, atoms. That also is important. A molecule is a combination of like or unlike. For example, uh, chlorine you take, it is one chlorine and another chlorine, like molecule, like atoms. For carbon dioxide you take one carbon and two oxygen, unlike atoms, like that. So these orbitals will be found in the molecules by atomic orbitals. So atoms independently they will have their own orbitals. When they become molecules, again the atomic orbitals will be combined to form the hybridized bonds. That is molecular orbital theory. Then metallic bonding, a bond formed by the delocalization, localized sharing of electrons in a metal lattice. Metal lattice means at each location some metals will be located. Lattice points means there at that location one atom, that location one atom, this location one atom. Like that, at different locations, different molecule atoms are located. That as a whole, it will be a lattice. So if it is a big lattice, it is a crystal, like that. So bond formed by the delocalized sharing of electrons in a metal lattice is called as metallic bond. Then when we are talking about the thermodynamics, we are talking about the energy levels. The energy changes especially between the heat and work. We know that energy can be transformed from one form to the other.
Yes.
Mainly when we convert the heat into work, work into heat.
Yes.
So internal energy of that system will change. So the transformation between heat and work is dealt in thermodynamics. This is based on the law of conservation of energy. Remember the first law of thermodynamics, nothing but law of conservation of energy, and it relates the heat and work balances. That is
Example,
first law of thermodynamics.
real time example for first law of thermodynamics.
For example, you are taking our bike is, for example, bike. Bike, what is happening here? Bike, petrol has hydrocarbon.
Yes.
Carbon and hydrogen material is there. When it reacts with the oxygen, it gives carbon dioxide and water vapor. So when initially it is a liquid, suddenly it becoming a gas. Its volume is 10 times or 20 times it is increasing. When the volume increases, what happens? The volume has to increase. In order to, when the volume is increasing, it will have a piston. It will uh, kick one piston to one direction. Piston problem, the piston problem, sometimes people say for the bikes or vehicles. So when the piston is moved, that means the chemical energy that is hidden in the chemical, this fuel is converted to heat. That heat, when it is increasing, the volume is increasing. When the volume is increasing, it pushes the piston to some extent. So when it is pushing, that means there is a work done. The chemical energy is converted to into thermal energy, that is heat. That thermal energy is again converting that into work by pushing out the piston.
Okay.
So that is work. So like that.
Second law of thermodynamics.
So for example, in the first law, I'll say first law of thermodynamics we are talking about now. That is the relation between heat and work. So how much heat for 1 kg? How much it will be? So how much work can be done? Similarly, what is the mileage and term? నా బైక్ మైలేజ్ 60 kilometers వస్తుంది, 40 kilometers వస్తుంది, 30 kilometers వస్తున్నట్టు. What is the reason? The engine efficiency is like that. If you take 1 liter of petrol for Splendor, it will be around 60 plus. For Bullet, it will be 40 because there is a balance between heat and work. And some energy is being lost as unavailable energy. That we'll see later. Then second law, it states that the entropy means when atoms or molecules are arranged in a systematic way, it's a measure of randomness or measure of disorderness. So entropy of an isolated system always increases in a spontaneous process. Even the entropy of the entire universe is increasing. It will not be the entropy change will never be zero or less than zero. Continuously, it is a spontaneous process going on. Then the energy associated with the chemical reaction that can be used to work where the negative values indicate the spontaneous reaction. Just now that we are seeing energy that is associated with the chemical reaction, when the reaction is happening, some amount of energy will be dissipated. As a result of that, the temperature will increase. That energy will be used for the work. So when heat is released, the energy change is negative. That means an enthalpy or energy of the products minus energy of the reactants. If it is negative, then it's a spontaneous reaction. If it is positive, that means what? Energy of the products is more, energy of the reactants is more. If it has to happen, we need to add energy. So that will be positive, like that. Then Raoult's law, it's related to the vapor pressure of an ideal solution, depending on the vapor pressure of each component and its mole fraction. If you take one liquid solution, in that there is some two components A and B. Component A has certain pressure, vapor pressure, its property. So that vapor pressure is proportional to the concentration. Or in other words, you can say mole fraction. Mole fraction is also nothing but a concentration. So the more the concentration of A, the more will be the vapor pressure. The less is the mole fraction, the less will be the vapor pressure. So that is the vapor pressure is depending upon concentration of the liquid solution. Then when two or more components are mixed to form a solution, that solution will exhibit some other property, deviating properties. So the properties that depend on the number of solute particles that is in the solution will affect the boiling point or freezing point, like that. So sometimes when the solute increases, boiling point will be elevated and its freezing point will be decreased, like that. A state where the forward and reverse reaction occur equal rates, maintaining the constant concentration of the reactants and the products. That is called as dynamic equilibrium. In other words, you can say it is a steady state dynamic equilibrium. At the equilibrium, the reaction system will have lowest possible energy. Uh, that is dy- dynamic equilibrium. At that instant, when when it reaches equilibrium, the concentrations of all the reactants and the products will be constant. Then Le Chatelier principle. Remember that when there is a reaction system and it has reached an equilibrium, if you adjust any one of the parameters like temperature, pressure, the concentration of the reactants or products,
Okay.
again it has to reach the equilibrium by changing its direction.
Okay.
Suppose, for example, A plus B gives C plus D. If you increase concentration of A, the forward reaction will increase. After that, it will reach back like that. If you increase the temperature, rate of the reaction will increase like that. So either external parameters like concentration, temperature, pressure is increased or decreased accordingly. The direction of the equilibrium will change. Just a moment.
Next. Next, what is redox reaction?
Reactions involving transfer of electrons, where one species is oxidized and other species is reduced. Suppose electrons is shifted. So the most suitable definition for the oxidation is removal of electron.
Okay.
One electron is removed, automatically it will be taken up by some other
Hmm.
molecule. So that is reduction process as well as oxidation process.
Hmm.
Reduction, oxidation together are called as redox reactions.
Hmm.
Then electrochemical cells. These are the devices that convert chemical energy into electrical energy. That is what fuel cells were saying. With the galvanic cells generating spontaneously electricity.
Hmm.
Then this Nernst equation relates the cell potential, how much potential electric potential is produced because of the concentration, temperature, and pressure in the electrochemical cells. That is, there is an equation.
Hmm.
Then reaction. You only prepared this material, huh?
Yes, with the Chat GPT licensed version,
But it's not in order actually.
it's okay, no problem. So according to JEE syllabus, it given. Okay.
That okay, but there is no order. In fact,
Hmm.
it has to come to certain order. Okay. The change in the concentration with respect to time is called as the rate of the reaction.
Hmm.
That will be affected by so many factors such as temperature, pressure, and concentrations.
Hmm.
The change of concentration of any reactant or product in unit time is called as the rate of the reaction.
Hmm.
Then Arrhenius equation. Actually,
Tell
this
me.
is a mix of a topic.
Hmm. No
There
problem.
is no order. Order is not there.
No,
Okay.
after the completion of your lecture, you can prepare in order. No problem. I'll give you chance. Okay.
Then Arrhenius equation this describes how reaction rates increase with temperature
Hmm.
due to the exponential increase in the rate constant.
Okay.
Arrhenius equation K is equal to K naught e power minus E by RT. That is Arrhenius equation.
Hmm.
K is a rate constant.
Hmm.
That rate constant is a function of temperature.
Hmm.
It changes exponentially with the K is equal to K naught into otherwise K is equal to A e to the power minus E by RT. That
Hmm.
means R is the universal gas constant.
Hmm.
E is the activation energy. T is the absolute temperature.
Hmm.
Okay, that is Arrhenius equation. Next, periodic trends. Uh, Trends in elements properties such as atomic radius, ionization energy. Ionization energy means the energy that is required to remove one electron
Hmm.
or electronegativity.
Hmm.
But if you add electricity electron to any element, how much energy it will be there? That is electronegativity across the periods and groups. So horizontal rows are called as groups, periods. Vertical rows are called as groups.
Hmm.
This arrangement is based on a certain principle.
Hmm.
Then D black and F black, mostly these are all called as transition elements
Hmm.
and intertransition elements. D black elements and F black elements.
Hmm.
These are all metals. They are known for their variable oxidation states. That means one atom will have different oxidation states. That means either it can share two electrons or it can share three electrons, like that.
Hmm.
For example, Fe2O3 hematite,
Hmm.
Fe3O4, like that. They will variable oxidation states. They will change. For that reason, they act as catalyst particles
Hmm.
properties and the formation of colored compounds.
Hmm.
Color is nothing but light reflection.
Hmm.
Then coordination compounds, the complex compounds where central metal ions bond to surrounding ligands with important applications in biological systems and industry.
What is the ligand?
Ligand means some group of molecules.
Okay.
For example, ammonia is there.
Hmm.
If you take ammonia, NH3 is ammonia.
Hmm.
If you take out one hydrogen, it becomes NH2 plus.
Hmm.
That is a ligand.
Yes. Yes.
సో మెటల్తో పాటు రియాక్ట్ అటాచ్ అయ్యేదని లైగెండ్స్ అంటాం.
Okay.
So they are very important in applications like hemoglobin, mainly blood law. Some chemicals, some elements, metallic elements will be there. Chlorophyll, magnesium will be there. Like that, metal ligands will be there. They are called as coordinate compounds. Then purification of the organic compounds. So when you are interested in organic compounds, how to purify them in their purest form, because the reasons are there why it is required in purest form is for some certain reasons. We'll see that. So there are various methods like distillation, chromatography, filtration, and so on. Many methods are there. For each method has its own principle. Based on a certain principle, we'll separate it out. For example, distillation you are taking. The distillation, if you take a liquid, it will become a vapor. Components present in liquid will disperse to the vapor in a certain proportion. All the elements will not vaporize. One element will vaporize less, one element will vaporize more. Based on that property, that is the principle. So each separation technique has its own principle. Based on that principle, we'll separate it out. Then isomerism means same molecular formula and different structures leading to different properties. If the structure is different, it will be its properties also will be different, but molecular formula will be same. Like that, those are called as isomerism, isomers.
Examples,
The
isomerism
properties.
examples.
Butane, you take normally butane C3H8.
Huh?
Isobutane is there.
Hmm.
C3H8.
Hmm.
Propane, C3H8. You see in our gas cylinder now,
Hmm.
that is isobutane.
Yes.
So like that, there will be change in structure, but the molecular formula will be same. Like that, there are some even you take fructose and glucose, molecular formula are same. The structure is different. Even molecular formula is same. Glucose will be some sweet, and this fructose will be so sweet. Same material. Because of the structure difference, will feel good taste. Like that. Alcoholants and phenols. Hydroxyl groups, OH minus group. If it is attached to open chain carbon atoms, they are called as alcohols. If it is cyclic, they are called as phenols. Amines means organic compounds containing nitrogen, classified as primary, secondary, and tertiary, based on the number of alkyl groups attached to the nitrogen. Then
So
carbohydrates,
simple,
carbon,
simple differences between alkanes, alkenes, and alkynes. How do you can differentiate?
alkanes means there won't be any double bonds or triple bonds.
Okay.
So each carbon will be having four different bonds. Suppose if you take, there are two carbons in between. There may be one bond between carbon and carbon. Sometimes there will be two bonds between carbon and carbon. C double bond C. That is alkene. Sometimes triple bond also will be there. C triple bond C. That is alkyne. So alkane, alkene, alkyne. These are all open chain hydrocarbons. That means there will not be any cycling order. It's an open chain. So alkanes are called as saturated hydrocarbons.
That is correct.
Alkenes and alkynes are called as unsaturated hydrocarbons because of their uh,
Rigidness,
double and triple
hardness.
bonds. So alkenes and alkynes are more reactive than alkanes because of their double bonds. ఆకలిగా ఉండడు ఎక్కువ తింటాడా మామూలుగా కడుపు నిండా తిన్నాడు తింటాడా like that. Then carbohydrates, carbon, hydrogen, oxygen. Just now we said na, what is that? Glucose and fructose, starch. These are all carbon, hydrogen, oxygen containing molecules. Proteins. Additionally, if some carboxylic acid groups are added and nitrogen, phosphorus is added, they become proteins. So these are the biomolecules essential for life involved in the energy storage, structural functions, and genetic information.
Hmm.
All information in the chromosomes. Chromosome is nothing but a DNA.
Hmm.
What you call that? Extracellular DNA. So when it is emitted out with the cell, it is called as extracellular DNA. So
Hmm.
all the information is coded in that. Because of that, only our children are having all two eyes, two ears, one nose like that. This is information is encoded inside
Hmm.
genetic information. Then for checking out quantitative analysis, how much amount it is there. If you take one solution, 10 grams of solution you are taking, how much component of A is there, how much component of B is there. By titrating with other materials. For example, some sodium hydroxide is there. How much sodium hydroxide is there? You want to know. If you use one sulfuric acid,
Hmm.
so sulfuric acid and sodium hydroxide when they're present, this much of sulfuric acid is required for treatment of this much of sodium hydroxide. So
Hmm.
known value of sulfuric acid if it is there, how much amount of the sodium hydroxide is there, you can measure. That is titrate analysis. Then when chemical combination, when the chemicals are being formed, products are being formed, there are fundamental principles governing these ways in which chemical reactions combine to form the products, such as the law of deficit proportions. 1 mole of A is reacting with 1.5 mole of B to give 3 moles of C. That is just type. So, in what proportions are there? 1, 1.5, and 2, like that. So, that is the proportionality of the reactants and mixtures. Then, atomic and molecular mass already we have seen. Empirical and molecular formula it is already it is seen. Chemically, stoichiometry already we have discussed. These are two equations. Then, psi, some people call it as chi also, chi square, chi n. So, variation of these functions with respect to the radius for 1s and 2s orbitals. This is not, I think it's not relevant here. Okay. It's a wave function. Psi is a function of
No,
radius.
you can't
For
say it is not relevant because IIT they can ask anything for making tough.
maybe at this juncture, in this order, it's not relevant.
You make it harder.
Talking
I
about
will I will send you after the class. You make
okay,
it duplicates, remove it, no problem. Okay.
okay. Next,
Why we are using variation of psi square and r for 1s and 2s orbitals? What is the reason?
psi is a function of r. That means it's a. I don't have full clarity over that. It is a function of r. That means it's wave function. It shows the amplitude. Uh, some properties are there, na? Decay ratio, something like uh,
Okay, leave it,
frequency.
leave it. Good if no
It's a
clarity then.
mathematical.
Hmm.
It's a mathematical equation.
Next.
Electron spin when electron is rotating around its own axis and revolving around the nucleus in a certain path, like called orbitals. If one orbital can accommodate only two electrons. In these two electrons, one electron will be rotating in one direction, the opposite, another electron will be rotating in another direction, clockwise and anti-clockwise. Whether this electron is clockwise or anti-clockwise, that will be decided again by its quantum number, spin quantum number. If electron is minus half, spin quantum number of an electron will be minus half or half. If it is minus, it is anti-clockwise. It is plus, it is clockwise, like that. That is electron spin quantum number. That's all. Next, Pagan's rule. It predicts whether a bond will be more covalent or ionic based on the charge and size of ions. This I don't actually forgot the concept.
No,
Then
try
when
now.
you take
By reading that sentence, you can give your own.
it says about whether a bond is more covalent or ionic. The nature of the Ionic nature. Ionic means it is purely uh, one electron is given by another donor
Mm.
to donor. So electron transfer will be there.
Mm.
Covalent means sometimes
Mm.
this will give one electron, this will give electron, together they will share. That
Mm.
is covalent.
Mm.
So whether it is covalent nature or ionic nature,
Mm.
to and what is the charge and size of those ions,
Mm.
that will be uh, revealed by Fasen.
Mm.
Then dipole.
Mm.
For example, magnet if you take, we call it as north pole one side, no, south pole one side.
Mm.
That means partial charge is one at one end, partial charge is at the other end. But atom is neutral
Mm.
or molecule is neutral.
Mm.
When it is neutral, one type of charge is existed one end, other that is what south and uh, north and south poles. So the dipole momentum is the product of the distance between those charges multiplied by the charges. Okay. Dipole momentum is equal to the distance between the dipoles and their charge. That is called as dipole moment. Dipole moment based on it is a property. Dipole moment based on some can say it is for what purpose it is. That is called as polarity. What is the polarity of this? Like that. Resonance in chemical bonding. It refers to the delocalization of electrons across multiple structures.
Yes. Yes.
When a substance is produced, existing in a crystalline form,
Mm.
that crystal will change its structure also because
Mm.
of the resonance of electrons. Electrons will, uh, and for no reason, they will be moving randomly. So
Mm.
when they are in a certain fashion, it will be the lattice structure will be like this,
Mm.
and when little disturbance among them randomly is happened, it will be having another structure. So multiple structures it is possible. You have seen in our phase diagram in chemistry. Even in the solids also two to three types of this uh, phase diagrams will be there. Phase call as there we can stop it. Then bond order, bond length,
Mm.
and bond energy.
Mm.
Bond order is the number of chemical bonds between two atoms.
Mm.
For example, you see carbon carbon bond. It is single bond.
Mm.
C double bond C double bond. C
Mm.
triple bond C, triple bond like that.
Mm.
While bond length and bond energy describe the distance
Mm.
between the atoms and the strength of those bonds,
Mm.
bond energy.
Mm.
Even for example, how this what you call fuels are giving some energy,
Mm.
carbohydrate or petrol, how it is giving some energy when a chemical bond is broken.
Yes. Then
So
only it
bond
gives energy.
liberated. So much energy will be liberated.
Mm.
That is the reason it is hidden energy. Bond energy.
What is the chemical form of petrol?
There is no specific formation. It depends on.
Mm.
It is a hydrocarbon, saturated hydrocarbon.
Okay. Like that only you can define for a petrol.
There will be energy associated with the carbon and the hydrogen. When
Mm.
this bond is broken, that energy will be liberated. That energy will be in the form of chemical energy, and that becomes heat. That becomes again work.
Mm.
Hydrogen, a strong intermolecular force where hydrogen atom is attracted to an electronegative atom in other molecules. That is called as hydrogen molecule. Electronegative atoms means p orbital mainly. Oxygen is also electronegative element.
Mm.
So system and surroundings. Thermodynamics generally we talk when we are considering about when you are observing something that is called as a system. Other than that, it is surroundings.
Mm.
That is thermodynamic definition.
Mm.
Entropy. It is a measure of disorderliness or randomness in a system.
Mm.
It's related to the second law of thermodynamics.
Mm.
Then enthalpy of combustion and formation. For example, fuels we are talking about now,
Yes.
methane or ethane, something like that. When it is combustion, that means carbon is reacting with oxygen.
Mm.
It gives carbon dioxide.
Mm.
So some amount of the energy will be liberated over there. So
Mm.
that is called as enthalpy of combustion.
Mm.
Suppose some product is produced, some big molecule is produced from its elements. While it is forming, it will lose some energy or it will take some energy. That is called as enthalpy of formation. While they are forming, some energy will be there. So these are the energies that we talk about. When these reactions are happening and they are reaching to equilibrium, in terms of their partial pressures or in terms of their concentrations, we will define the equilibrium constants. They are called as equilibrium constants with respect to pressure or with respect to concentration. They are nothing but the ratios of product of products divided by reactant. When the problem comes, I will explain it later. An example I will tell.
So, what is meant by Kp and Kc stands for, and give examples for
It's
Kp
a
and
rate constant. It's equilibrium constant.
Hmm.
Say, for example, you take one pen and paper. I'll explain you.
Yeah, no problem. Tell. What is the Kp stands for? What is Kc stands for? You tell that.
Equilibrium constant based on pressures
Huh.
is Kp. Equilibrium constant based on concentrations is Kc.
Okay. Later we'll see some
Uh,
examples. Next.
so ionization of water and pH. When water is getting analyzed, ionized means H2O is a molecule.
Hmm.
We can convert that molecule H2O into H plus and OH minus. We are making it into ions, H plus ion, OH minus ion. That is called as ionization. And
No,
if the
that
concentration of the
ionization
hydrogen
layman
ion,
concept you tell me. Ionization means you are reducing or increasing.
we are making an ions.
Okay. What is ion?
H2O is a molecule.
Yes, that I know.
Ion is an atom or a group of atoms
Hmm.
having some charge.
Yes.
If it is positive ion, it is cation we say. If it is negative ion, it is anion we say. So
Yes.
see here it is H plus and OH minus.
Yes.
Water is ionized into that form.
Okay.
So if you take up that H plus concentration, how much amount of H plus is there?
Hmm.
Negative logarithm of hydrogen ion concentration
Hmm.
is pH.
Hmm.
pH we are defining negative logarithm of
Hmm.
hydrogen ion concentration.
Hmm.
That value will be between 1 to 14.
Hmm. Okay.
So neutral, if pH is 7, it is neutral. If pH is less than 7, it is acidic. If pH is more than 8, 7, it is alkaline or basic.
Hmm.
So pH is a measure of a substance, whether it is acidic or neutral or it is alkaline.
That is decided by the pH value.
Yes. So
Hmm.
many of the biological reactions depend upon pH and temperature. The
Yes,
temperature
correct.
changes, pH automatically will change.
Yes.
If pH change, temperature will sometimes change. So if the value of pH changes, for example, the hormones, enzymes, all that will denature. That means their structure will damage. That
Hmm.
is the reason when cell maintains a certain pH, then only we will be with good health. That is why when the pH is changing, the temperature will also be changing for people when we are feeling um, fever.
Hmm.
Because of that variation in the pH or variation in the pH when it is changes, the concentration also will change.
Hmm.
సో సెల్లో ఉండాల్సిన ఎలిమెంట్స్ ఉన్నంత వరకు ఉండకపోతే ఆటోమేటిక్లీ విల్ ఫీల్ ఫీవర్
Hmm.
బాడీ టెంపరేచర్ పెరిగిపోతుంది దట్ ఈస్ ఫీవర్
Hmm.
సో కామన్ అయాన్ ఎఫెక్ట్
Hmm.
reaction when the reaction is happening,
Hmm.
if any ion that is common
Hmm.
to both the reactants or products,
Hmm.
that will be affected by the presence of that. That is
Hmm.
called as common ion effect. For example, sodium hydroxide solution is there. If we add sodium chloride, direction of the reaction will change.
Hmm.
That is some example. Then electrolytic and metallic conduction. Metals normally what happens? There will be free electrons throughout the lattice. So because of momentum of the free electrons, electricity passes. Then if you take an electrolyte, that means you take a solution and keep two electrodes between apart. One will act as cathode, one will act as anode. So from cathode to anode,
Huh?
elec- from cathode to anode, electrons pass.
Ah.
From anode to cathode, positive charge will pass.
Mm.
That is electrolytic conduction.
Mm.
Then cell potential and Gibbs energy. When
Mm.
you are taking two electrodes, you know what is the electrode? Positive electrode, negative electrode.
Yes, yes. Yeah.
So that potential will depend upon
Mm.
cell free energy of change or electrochemical reaction. So cell potential and Gibbs energy change.
Now, if potential difference is zero, what it indicates?
There is
Potential
no
difference
no
is
no
minus
flow of
1.
no flow of electrons. There is no flow of production of current electricity.
Mm.
If electron is moving, then only electricity will be produced. Otherwise, there won't be any electricity.
Mm.
Then collision theory of gaseous reactions. It
Mm.
states that the reactions occur when particles collide with sufficient energy and correct orientation.
Mm.
And if the molecules are activated to form the product,
Mm.
then the product will be formed. So
Mm.
continuously, the molecules one with each other
Mm.
collide.
Mm.
ఒకదాన్ని ఒకటి కొట్టుకుంటూనే ఉంటాయి
అవును.
అట్లా.
Mm.
So law of periodic properties.
Mm.
Elements show periodic trends in properties such as electronegativity and
Mm.
atomic sizes across the periodic table.
Mm.
ఇది ఆల్రెడీ డూప్లికేషన్ వల్ల.
Mm.
Lanthanide contraction.
Mm.
Lanthanide elements కి
Mm.
50 to 57 to 17 అంత వస్తుంది.
Mm.
So the gradual decrease in the size of the lanthanide atoms due to poor shielding of F electrons. ఎలక్ట్రాన్స్ ఒకదానికి మధ్యలో ఎక్కువ ఇది ఉండడం వల్ల
Mm.
సైజు తగ్గుతూ ఉంటాయి.
Mm.
So that is called as lanthanide contraction.
Mm.
Werner's theory of coordination compounds.
Mm.
It describes how metal atoms bond with surrounding ligands in a complex ions. That is
Mm.
Werner's theory.
Mm.
Crystallization is a separation process where a solid forms from a liquid or gas, separating it from the impurities. Crystal is the purest form. For example, where the salt we are taking or sugar we are taking, we are crystallizing that.
NaCl I am taking. Tell me.
NaCl actually is a solution, brain solution. It's called.
Mm.
So NaCl when it is exposed to air, normally or exposed to sunlight, the vaporized water will evaporate and NaCl crystals will be there.
Mm.
Or if you take cane juice, sugar cane juice,
Mm.
if you heat it, part of the water will evaporate,
Mm.
and if you cool it again, it becomes crystallized.
Mm.
So it's a separation process to get the solids into purest form.
Mm.
Then qualitative analysis in organic chemistry. So if any element is there in that,
Mm.
to detect that elements
Mm.
like nitrogen, sulfur, halogens,
Mm.
whatever, that is
Mm.
called as qualitative analysis.
Mm. Without nitrogen, sulfur, and halogens in organic compounds, what we can call it as?
Yeah, I think that is why this theory is not correct. Qualitative analysis for anything we can do. It is example like
Okay, it's just nitrogen,
anything
sulfur, and
qualitatively whether it is
halogens.
present or not we can check. For example, you take alcohol.
Mm.
Alcohol consists of ethanol
Yes,
mainly.
yes.
Sometimes not sir if you take in that methanol also will be there. కల్తీ సరాయి సచ్చారు అంటుంటారు.
అవును తెలుసు ఇథనాల్ లేకుండా ఏది
If that
ఉండదు మత్తు
methanol is
పదార్థము
present in the
మత్తు
ethanol,
పదార్థము యా
people will die.
యా
So to check whether that methanol is there in that or not, there is a test
ఎస్
that is called as qualitative test. To how much amount of methanol is there in that? That is qualitative test. The tetravalence of carbon. Carbon can share 4 electrons with surrounding atoms.
Hmm.
So that is the most specific. If it loses 4 electrons,
Hmm.
it gets uh, what you call octet rule,
Hmm.
or if it takes the 4 electrons, it gets octet rule. That is the సవ్యసాచి లాంటిది అనమాట.
Hmm.
అర్జునుడు సవ్యసాచి అంటాం కదా.
Ah.
సో కార్బన్ ఇస్ multiple, either it can become positive or it can become negative. That is the reason carbon is abundantly available in the universe, Earth.
Yes.
So carbon forms 4 covalent bonds, enabling it to create a wide variety of organic compounds.
Hmm.
So maximum number of carbons that electrons that can be accommodated by an element is 4 only.
Hmm.
If it loses 4, it get a acted relation.
What
If
are
it
the four
is
covalent bonds? Can you explain?
sharing of one, if one electron is shared, that is one covalent bond.
Ah.
Two
No
electrons
bonds.
are shared, two
Ah.
covalent bond like that.
Hmm.
Covalent bond is nothing but sharing of electrons one with each other.
That is called covalent bond. Here,
Yes.
tetravalency of this forms four covalent bonds. What are the four covalent bonds?
Ah, if I give one electron, another person will give one electron, that will be shared. That is one covalent bond.
Okay.
And I
Next.
will take some other person electron, and again in this way I will share. That is one covalent bond.
Hmm.
And with some X and Y like that. 4 covalent bonds, it will enable to create variety of organic compounds.
Okay. Next.
Atla.
Free
Free
radical.
radicals.
What
Freely
is
existing radicals.
radicals?
Charged molecules in radicals అంటాం.
Okay. Charged
Sometimes they
molecules is
will exist
nothing
as
but
freely.
radicals.
Carbocations and carboanions.
Hmm.
Carbon related anions, cations. Cations into positive, anions into negative.
Avunu.
The reactive species in organic chemistry where atoms or molecules possess unpaired electrons, positive charges or negative charges
Hmm.
as free radicals.
Hmm.
Then hyperconjugation.
Hmm.
ఒక్క నిమిషం ఉండు. నా టైం అయిపోయిందా?
Okay.
Shall we take one gap for 1 hour? సొంత ఊరు రావాలా?
75 బిట్స్ కనీసం 175 75 కూడా చెప్పకపోతే ఎట్లా 1 అవర్
75 చెప్పేస్తారా?
చెప్పు.
Hyperconjugation, that is delocalization of electrons in a molecule that stabilizes carbocations and contributes to the structure of organic molecules.
हाँ बीम बोलो बीम.
Organic,
हाँ बीम
huh?
बोलो बीम.
Really?
हाँ अभी 46 चल रहा है बीम.
और सर मैं आपको एक फॉर्म भेजेगा.
हाँ हाँ हाँ
आपको आपको फॉर्म फिल करना है.
हाँ
और फिर ब्लू इंक से आपका
Right.
थंब प्रिंट देना है उस पे.
हाँ 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 मैं दे दूंगा.
सारे फिंगर्स का प्रिंट चाहिए.
हाँ मैं दे दूंगा.
वो देके
हाँ
फिर उसे स्कैन करके मेरे को भेजना है.
हाँ भेजता मैं.
हाँ ठीक है, तो मैं आपको सर फॉर्म भेजता है.
हाँ सिर्फ एक ही हाथ का सभी का.
वो थैंक्स राइट. वो आप देखना, आपको दोनों
हाँ, हाँ.
लिखा होगा, सब उसमें लिखा हुआ है.
हाँ 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 हाँ
लेफ्ट राइट फिंगर ऐसे लिखा हुआ है.
हाँ 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 उसमें मैं ब्लू इंक पे करना पड़ेगा. ओके.
ब्लू इंक से आपका फिंगरप्रिंट्स
हाँ 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 हाँ, मैं कर दूंगा.
क्या भेजना स्कैन. हाँ
हाँ
ठीक है सर.
ओके.
भेजता है.
हाँ
बाकी मैं फॉर्म आपका यहाँ फिल कर रहा है.
हाँ